All right, so now we are going to be graphing some absolute value functions. When you graph absolute value, you want to figure out where the vertex is. It kind of looks like a parabola, except it's V-shaped. It comes at a point down at the vertex. Now this could be upside down as well, but that's the basic shape of an absolute value graph. So what you want to do is you want to think about how do you get 0 inside the absolute value. So you can just take whatever's in there and set it equal 0, and of course then x there is 0. So if I put 0 in there for x, I take the absolute value of x, um, we know that absolute value of 0 there is 0 because it's the distance. What absolute value is distance from 0 on a number line. So 0 is 0, 0 distance from 0 on a number line. All right, so now if we put 1 in there, how far is 1 on a number line there from 0? So if you kind of think of a number line, 1 there is 1 from 0 on a number line. How far is -1 from 0 on a number line? It's also 1. So basically the absolute value of 1 is 1, absolute value of -1 is 1. So now we can go ahead and we can graph that 0, 0, -1, 1, 1, 1, and connecting that like a V. And there we have it. We could also graph that out on a graphing calculator. Let me show you how to do that. You can go to your y equals, and then we can hit the math button. And if you see underneath the math button, we can, at the very top it says math num cpx drb. We want to go over to the num key at the very top. So we're going to hit the right arrow to do that. And when you do that, you'll see right away it comes up to the screen there. Number 1 there says ABS. That is your absolute value key. So I can hit enter, and then the absolute value symbols will come up. So now what I can do there is I can put X in the center there, and then I can go ahead and just hit graph. And it will graph that out for us. So there it is, and you can see the table of values. We can see 0, 0, 1, 1, -1, 1, negative 2, 2, 2, 2. So again, we need to know where it comes together there. So that's your basic absolute value graph. So I'm going to go ahead and go through the next one here. Let's look at another one. So again, what are we thinking? We need to figure out where it comes to a point there. So you got to think how get 0 inside there. Well, if you don't see it, just go ahead and set x plus 3 there equal to 0 and solve for x. So I just went ahead and subtracted 3 from both sides, and I got x equals -3. So how do you get 0 there when x is -3? So if you plug -3 in there, -3 plus 3 is 0. Absolute value of 0 is 0. All right, so now I'm going to plot that, -3, 0. And then I'm going to pick an x value to the left of -3 and an x value to the right. So I'm going to pick -4 and -2 and plug those in there. So I've got -4 plus 3. -4 plus 3 is -1. Absolute value of -1 is 1. So basically, people kind of like to think of, too, that when you put something into an absolute value, it always comes out positive. -2 plus 3 is 1. Absolute value of 1 is 1. So -4, 1, and -2, 1. And then you can connect those points. So if you kind of think about this, normally it was sitting over here at 0, 0. And the normal graph here, when they did the absolute value of this one here, was y equals absolute value of x. This blue one over here is y equals the absolute value of x plus 3. So if you think about what happened there, the green graph there just basically shifted over 3 to the left there. So when you've got something in here that you're adding in here, it shifts at 3 left from 0, 0. So you can have that same green graph, and we just shifted 3 to the left. So if that's true when you're adding, what do you think happens when you subtract? Well, I'm thinking this one here is going to shift it 3 right from 0, 0. So let's kind of think about it. Again, how get 0? You get 0 in there when, well, we'll just do the math, when x is 3. So I can add 3 to both sides, get x all by itself, and x ends up being 3. So we get 0 in there when x is 3. And if you put 3 back in there, 3 minus 3 is 0, absolute value of 0 is 0. So 3, 0 is my ordered pair there. And like we said, the normal one here, the y equals the absolute value of x, we call that a parent function. There's nothing being added or subtracted to or multiplied by it. So then what happened to that? It shifted it 3 to the right. All right. So then if you pick an x value to the left and to the right there of 3, like 2 and 4, and plug it in there, 2 minus 3 is negative 1. Absolute value of negative 1 is 1. 4 minus 3 there is 1. Absolute value of 1 is 1. So we've got 2, 1, and 4, 1, and we can connect our points. So inside there, if you're subtracting, that's going to move it right 3. If you're adding inside there, it's going to be moving it left 3. So now let's look at another one. Now it's not inside the adding and subtracting, they're on the outside. What do you think that's going to happen? Well, let's see what happens. Again, no different from before. We want to think, how do we get 0? We get 0 in there when x there is 0. So then what's the absolute value of 0 plus 2? Well, the absolute value of 0 is 0, plus 2 is 2. So I can plot the ordered pair 0, 2. All right. So, and then I'm going to pick an x value to the left of 0 and to the right of 0. So I'm going to pick negative 1 and 1. So absolute value of negative 1 is 1, plus 2 is 3. Absolute value of 1 is 1, plus 2 is 3. So negative 1, 3, and 1, 3. And connect my points. Whoops. So again, if you kind of compare it to the original one here, 0, 0, 1, 1, negative 1, 1. Well, what do we know about that one? The blue one there, if this one, the green one here is y equals absolute value of x, and the blue one up here is y equals absolute value of x plus 2. What happened with that one? It just shifted it up 2. So this one here is shift up 2. So if adding on the outside there shifts it up 2, what does subtracting on the outside do? That's going to shift it down 2. So again, we'll kind of compare that. So I'm going to quickly put on this graph that we had at the very beginning. This is y equals absolute value of x. So again, no different here. We're thinking this is going to shift it down 2. And again, we're going to think, how get 0? We get 0 in there when x is 0. So let's plug 0 in there. Absolute value of 0 minus 2 is negative 2. So 0, negative 2. I'm going to pick an x to the left of 0 and to the right of 0. So negative 1 and 1. Absolute value of negative 1 is 1, minus 2 is negative 1. Absolute value of 1 is 1, minus 2 is negative 1. So negative 1, negative 1, and 1, negative 1. Connect my points there. And again, you can definitely see the blue graph there shifted down 2 from the green graph. Just another way of just graphing that out, just seeing the shifts. All right, so now what happens when there's a negative on the outside? Well, if you remember, negatives on the outside with parabolas, so if you had a quadratic here, and I told you that this one was y equals x squared, and if I told you this was a negative x squared, Remember, that's going to open downward. Well, the same thing is going to happen with the absolute value. So absolute value of x is going to look like this, but y equals negative 1 times the absolute value of x is going to be upside down. So if I graph out my green graph here again, it's just going to be upside down, the same thing. So you could just go ahead and put that in there. Or, again, we can think about how it gets 0. You get 0 in there when x is 0. Do your table. Absolute value of 0, 0 times negative 1 there is 0. And then putting negative 1, because that's still left there of 0. Absolute value of negative 1 is 1 times a negative 1 on the outside just gives me a negative 1. Putting a 1 in there, absolute value of 1 is 1 times a negative 1 on the outside there is a negative 1. So we've got negative 1, and we've got 1, negative 1. And we can connect those. So again, this red graph is y equals negative absolute value of x. So I believe we did this one. Yeah, we already shifted this one up too. So let's look at this combination graph here. We've got y equals negative, and then inside the absolute value there, you've got x minus 3 and then plus 4. Well, you could think about everything that's going on here. What does this do? This shifts it 3 to the right. What does this do? And up 4. And then what does this do? Flip it upside down. So we could just hand graph that out from 0, 0. So remember, this was our original one here. If we think about moving that one, we could shift it to the right 3, 1, 2, 3, and then up 4. 1, 2, 3, 4. And then it's supposed to be upside down. Oops. This kind of has a slope of 1, 1 coming down. So it's basically going over 1 and then down 1. So that's what the graph looks like, just kind of doing it by the shifts. But we could also do it by looking inside there. How do you get 0 inside? Set that equals 0. Solve for x. And you get x equals 3. So let's put in 3. So then 3 minus 3 plus 4. That gives me 0 inside the absolute value times a negative 1 on the outside is 0. And 0 plus 4 just gives me 4. So my starting point there is 3, 4. And then we can pick an x value to the left like 2, and x value to the right like 4. So then I can go 2 minus 3 there. 2 minus 3 there is a negative 1. Negative 1 times the negative, or absolute value of negative 1 is 1, times the negative 1 is negative 1, plus 4 gives me 3. And then next one here, absolute value got to do first, so it's treats it as a parenthesis. So 4 minus 3 there is 1. Absolute value of 1 is 1 times the negative 1 is negative 1, plus 4 is 3. So you got 4, 3, and we've got 2, 3. And then you'd simply connect those. So there's my combination graph. All right, so I think we got time for one more. So this one here, how do you get 0? You get 0 inside there when x is 1. So go ahead and put it in your table. 1, plug 1 in there. So we get 2 times absolute value of 0 is 0. 2 times 0 is 0. Minus 3 is negative 3. And then pick something to the left there of 1, negative 3. Pick something to the left. So like 0 and 2. So we get 2 minus 3 is negative 1. And is also negative 1. So I've got 0, negative 1, and I've got 3 or 2, negative 1. Connect, and there's our graph.